Students, now we will move forward in our chapter biodiversity and conservation. So first we will learn what is species area relationship. So a German naturalist and geographer, Alexander von Humboldt, observed that within a region, species richness increases with the increasing with the explored area, but up to a certain limit. It means when we are increasing the uh, area of a particular geographical region, then the number of species was also increases, but it happens up to a certain limit. And the relationship between the species richness and the area for a wide variety of taxa turns out to be a rectangular hyperbola. And on a log scale, the relationship of a species richness with the area is a straight line. Now we'll see the formula for that is log S is equals to log C plus Z log A. Here A is the area, Z is the slope uh, of line, or we can say the regression coefficient, and C is the y-intercept, and S is the species richness. The value of Z, which is regression coefficient, lies generally in a range of zero point 0.1 to zero point 0.2 regardless of taxonomic group or regions. Now we'll see the importance of species diversity in the ecosystem. So what we'll see here, that what is the need or what is the essentiality of the species in the ecosystem. So it has been believed that the communities with more species generally tend to be the more stable as compared to less species area. And the stable community has no much variation in productivity from year to year. So it is either resistant or recover if any disturbance created by human or immigration. It means if there is any change, if there is any change comes in a particular geographical area or in a community, and if it is a stable community, then either it will resistant it, uh, or if there is any change, then it will automatically recover it. And David Tillman's experiments revealed that a plot with more species has or more rich uh, diversity has a less year-to-year variation in total biomass also, and increases diversity contributed to a higher productivity. It means the stable community will have more biomass and more productivity, and it will be constant year to year. And the rich biodiversity is not even essential for the ecosystem but also beneficial for the human race also. So there is a hypothesis, Rivet Poppet hypothesis. So there was a scientist and ecologist, Paul Ehrlich, gave this hypothesis to understand the contribution of species richness, and he compared each species with rivets in the body of airplane. This hypothesis explains as the first is species to be the rivets joining all parts together, and the second is if there is a situation in second step, and the step is if every passenger traveling in the airplane starts taking rivet home, causing species to become extinct. Initially it may not affect the flight safety, or we can say, or the proper functioning of the ecosystem, but over a period of time the plane becomes weak and dangerous situation comes. Here the species becomes endangered or even extinct. It means if we will remove the species one by one, initially it will not harm to the ecosystem, but after some time we can see a drastic change or dangerous situation in that particular ecosystem. Now we'll see loss of biodiversity. In this heading, we will learn what is the situation of our biodiversity. So the human activity and interference is the main reason for the loss of biodiversity and the colonization of the tropical Pacific islands. But the human has led to the extinction of more than 2,000 species of native birds. And according to IUCN 2004, in last 500 years, 784 species, including 338 vertebrates, 359 invertebrates, 87 plants, became extinct now. And the last 20 years alone has witnessed the loss of 27 species. Some examples of recent extinct are dodo from Mauritius, quagga from Africa, thylacine from Australia, stellar sea cow from the Russia, and the three species of the tigers also from Bali, Javan, and Caspian. Extinction across taxa is not a random, but some groups like amphibians appear to be more vulnerable to the extinction, and about 15,500 species are facing threat to the extinction. At present, 12% of the all bird species, 23% of mammal species, 32% of all amphibian species, and 31% of all gymnosperm species in the world face the threat of extinction. So there is a need to conserve these biodiversity. Thank you.